Good morning, everyone. All the attendees, welcome to NIL webinar. Today's topic will be OT, uh, control risk and achieve compliance. First, a couple of words about NIL. We're part of Conscia Group, based in Slovenia, in Ljubljana. We are a globally recognized system integrator, and we're a managed services and training provider with over 200 employees. Most of our customers are large and medium-sized organizations, companies. We were established in 1989, and since 2019, we are part of Conscia Group. A couple of words about Conscia. We are a European-based system integrator with over 1,000 large customers, mostly in Northern and Western Europe, but we also have businesses in Spain and in Slovenia. We, at the moment, have a little less than 2,000 employees, of which over 1,000 are engineers and analysts. A couple of words about myself. I have been working in IT since 2002, and I've worked in almost all the IT positions from system support to architecture and strategy. I've been part of various stories. So I've been on the both sides of the coin, working with service providers as well as working with industrial companies, mostly in the area of digitalization support with focus on industrial networks and cybersecurity. I am ISA active member, part of several work groups, and currently a certified cybersecurity expert for IEC 62443. I've been working on other topics related to cybersecurity as well, mostly industrial cybersecurity incident command system, of which I'm a promoter. And I've also been a regular member of LockShield's team member for SCADA systems for Team Slovenia. So today's topics are several, let's say, chapters. First one is the presentation of the IT OT story, IT versus OT. Then we will jump to a couple of words about NIS2 and move on to IEC 62443 and some practical aspects of it. And then we will finish with a recap of what was discussed. So IT versus OT, it's always been a tale of two worlds that are colliding, meeting, intersecting, whatever word you want to choose, but it was always really a stark opposition or comparison, or sometimes competition even. And I think this illustration shows really nicely some of the main aspects of each of them. But I think we should take a look first at the conceptual differences, the concepts of, let's say, approach. I'm sure you're familiar with the CIA triad. And when we talk about IT and OT, we have the diametral opposition, meaning in IT world, usually the confidentiality is the one taking highest precedence over integrity and availability, while in industrial worlds, we usually have the availability as the pinnacle, as the end goal. So the availability of control data at all times, at all the relevant endpoints. Of course, integrity and confidentiality are not neglected in this case, but usually the confidentiality in OT means you have some numbers, you have some process data, but without true context and without a real analysis, you're not able to make out what is happening. So I'm guessing most of you have met or are working with OT, are familiar with it. Then I'm sure you will recognize at least some of these topics. When I was preparing the slide, I wanted to choose the most obvious ones, and I think there are some that really jump into the forefront, but there are some that are thankfully not so common. For example, injuries, safety systems malfunction. Luckily, we don't have a lot of those cases related to cybersecurity in OT, but there are some, unfortunately. So if you're familiar with these, then we can probably talk also about some of the differences. Why do we have the situations from previous slide, and where do they come from? So there are there are some differences between IT and OT in terms of environment, and I like to put them, or they're usually put into several categories, and those that are really, in my opinion, important are, let's say, related to the purpose. So on one hand, we have data transfer in office environments, business data transfer. On the other hand, in OT, the purpose is control of production, control of the process, which usually, as already said, contains different kinds of data. Then we have the field of responsibility. I have encountered this one, I think, quite a bit in my previous work as a consultant, because on one hand, in IT, we have IT experts that have their own duties, and their work can also be outsourced, and responsibilities can sometimes be also shifted through SLAs. On the other hand, in the OT world, despite having some necessity for IT knowledge, the pure focus is on the electrotechnical qualified personnel. And there are some standards that regulate who can work on OT equipment and what kind of prerequisites are necessary. Because if we take a look at a typical IT server room and a typical OT system, I would say the chance of electrocution is somewhat higher in OT. And this requires different skill sets, different trainings, and in the end, also responsibility cannot always be shifted. For example, environmental health and safety issues, for example, a natural disaster coming from a chemical plant, cannot be offset by writing or by signing an SLA with external provider. You're always responsible for your location and whatever comes from it. Then we have location of the machines. Of course, in IT, we have the so-called carpeted environment, which means very equipment-friendly environment in the data center as well as in the office. And it's usually climate controlled. So it's not really often we see temperatures rising above, let's say, 40 degrees Celsius. That's really the extreme. But mostly it's kept in the 20s. Then on the other hand, OT equipment is located, because of the purpose of the machines, in the production, in the vicinity of the equipment that they're controlling. There are, of course, some exceptions, but I wouldn't say that's the point of today's talk, maybe for some other time. But from the reliability perspective, the equipment is usually co-located in the machines. Communication cycles themselves, I believe we're all really familiar with office cycles, where, let's say, typical VoIP is about 10 milliseconds. 10 millisecond cycles are quite good for video conferencing, for talking. So for the most sensitive, the parts of the IT communications that we see the most. On the other hand, I chose specifically one of the more extreme examples. We have cycles of about 31 microseconds, but these are really used only in some examples with motion control. And the communication protocol is Profinet isochronous real time. So this is really the extreme, but in typical production, communication cycles are between 1 and 4 milliseconds, but they need predictability. So there is no room for error if you have, for example, too many missing packets in the communication. Topology, That's one of the more familiar ones. Also, especially for everyone from IT. Colleagues I've met usually recognize the OT topology really fast because it's flat, horizontal. It's like a mismatch of everything. Where in opposition to the OT side, in IT we have nice hierarchical communication with equipment being vertically organized up to the internet level. Availability. Sometimes we can argue that availability in IT and OT should be similar. Sometimes also companies require 24/7 availability of IT services, but usually it's integration services or automation services. But in production, if it's running 24/7, then this means it has to run 24/7. In some vertical industries, especially in process industry, there is no room for restarting something or maybe taking something offline just to patch the system or something like that. Life cycle itself, sometimes that's the root cause of all the issues that IT people see in OT, because in IT, life cycle is usually tied to the accounting data, or let's say accounting properties of equipment and the replacement of equipment. For example, for mobile devices, it's between 2 and 3 years. For PC servers, it's about 5 years. But this means that equipment and software is regularly updated, and there are no issues. In OT, life cycle is tied to the machine itself, because computers are, let's say, part of the system integration of the machine, and it can be up to 40 years. In some of the industries, maybe mining, some kinds of chemical industry, equipment can work for up to 40 years, perform their tasks, and the computer systems, so the let's say cyber components, are not that, despite being the lower cost, they still make up the whole machine and cannot really be changed individually. If we continue to next slide, we're still with the lifespan of the equipment, as already mentioned. On this slide, we'll be talking about, let's say more specifically, about the security properties that are, let's say, coming from this IT-OT comparison. Lifespan, of course, plays some role, because we all know patching old systems can sometimes be a difficult task. As well as lifespan, software cycle and upgrades are also tied to the lifetime, and usually with age comes this inability to patch or difficulties patching. This also means, as far as security software is concerned, if we have old hardware, if we have outdated software, we also have issues with the installation of security software, like endpoint protection, antivirus, anti-malware software. And compounding this issue, further making it worse, is heterogeneity of assets. Usually in IT world, all the PCs come at least from the same vendor, and there may be several types of machines. Servers come from the same vendor usually. Organizations have a lot of control over their procurement process. But in OT, assets come as part of production lines, as part of machines. And if the life cycle is between 10 and 40 years, this means that in the 20-year period, there can be machines from several different vendors with different hardware installed. So we have this high heterogeneity and a lot of vendors, different versions. And this is also part of the security concept, also influences the security concept itself, because in IT we have this standard-based approach where policies are overarching or encompassing entire organizations. They are enforced for all users, for example. They're enforced for all machine types, for example. But in OT, the approach that's, let's say, best working so far and has been proved in past decades is using risk-based approach on the base of IEC 62443. It has proved itself as the de facto global standard. Physical security also plays a role because, as already mentioned, we have carpeted space in IT, we have secured rooms, equipment is always under control. But in OT, equipment is spread across organization. Sometimes it's moving around in some of the verticals. Equipment is traveling, so in transportation, for example, or some let's say logistics scenarios, and we cannot really control the physical aspects of security, or we have to take some countermeasures to control it. And the last one, already mentioned a couple of slides ago, the safety. So in IT, we don't have the relevance of safety in any kind of way because equipment is not a danger to users. Maybe users are danger to equipment, but not the other way around. On the other hand, in OT, safety plays a role because we are protecting not just equipment from malicious acts of people, but people and the environment from malfunction. As already mentioned, some kinds of chemical industry, or sometimes in discrete industry where we have robots, where we have moving AGVs, for example. We have to take care of the people as well. So it's really an important aspect of OT to provide a safe shutdown. So in all the time we have to maintain control of the processes, and when something goes wrong, our measures must contain also safe shutdown of equipment. We're moving on to next chapter, NIS2, and I'm sure the date October 17th, 2024 means something to you. I'm sure if you've met NIS2, then you know this date. It was the date by which all the national laws of European Union member states should include NIS2 provisions in their national legislature. So what happened? Of course, not a lot of countries, at least none that I know of, were done by that date. There were some exemptions, but most of the countries did their work by today. And what we now have, so if you thought that NIS2 was difficult, the provisions were problematic, and the enactment would be a task, we're now dealing with, these are not all the laws, by the way, from the European Union, but I have chosen a few implementations from EU member states. And what they have in common, of course, it's NIS2. The provisions have been enacted, but what also happened is each country chose also to perhaps do it their own way. So we have, let's say, Germany. Germany has a really good critical infrastructure law that compounds their central IT cybersecurity law, and it's quite tight, but general. But some other countries, for example, like France, or perhaps Italy or Hungary, have chosen to make some of the requirements stricter. So, for example, in some countries, they have different categories of criticality for equipment. In some countries, for example, in France, there is a mandatory external review of cybersecurity, and it's also related to to OT security. So, what I wanted to point out with this slide is that if you are operating in more than one country, you have to be aware of the, let's say, differences in law, and you have to make sure that you're compliant with your own law, and you're also compliant with the law of the country that you're working in. And as far as NIS2 at this moment is concerned, there are a couple of things that I'm thinking a lot about. So one is from the previous slide, the actual technical requirements and how to manage them, how to manage compliance when you are, let's say, a medium or large business and you're not limited to just one country. What kind of challenges does this pose? Then we have the topic of supply chain. This is also one important issue that brings with it a consideration for you as how to manage suppliers, because this is also one of the provisions in NIS2 and also in national laws. You as a company that must observe NIS2, so if you fall under NIS2, then you also have to, in a way, manage your suppliers, even if they are not NIS2, even if they don't fall under NIS2 provisions. And this offers, I would say, it's a nice task, quite a big one. And as already mentioned, this cross-border operations can pose some challenges. Now, how to deal with that? I think 1 hour is really not enough to go through all of this, but you can start with small steps. And as we'll show in the next half of the webinar, there is a way that you can take. There are steps you can take to move yourself toward a position where NIS2 will not be just some requirement that you have to fulfill, so you have tick marks in your audits, but I more consider it as a jumping point. So you get to this point of, okay, we are now NIS2 compliant, but this is just a point from where you start to have to implement the actual required cybersecurity, not the one that will make you compliant in the eyes of your governments, but will make you resilient and secure for the future. And of course, one of the best building blocks in this case is IEC 62443. It's actually, during the years, it has proved itself as a central standard. There are some national frameworks as well that work well, that can be implemented, but for global use, it's basically one of the cornerstones. Yeah, what can we say about it? A really short overview. We in IEC 62443, we don't have one standard. We have 4 groups of documents, from general documents to policies, procedures, system, part, and the component. Each of them covers specific topic, and I would mostly focus on the last 3, because first one contains documents that are dealing with general concepts, models, descriptions. Some of them are actually still in work in progress. But we have a couple of interesting documents in the policies and procedures part. So we have the security program requirements for industrial automation control system asset owners. This is one of the foundations for implementing a security management system in OT. And there are also a couple of documents here that can help with patch management. So specifically for preparing processes and procedures for patch management. And another one that I have used in several occasions, for example, for service provider management and for rating service provider management. It's mostly, yeah. I don't want to go into details now because we will maybe lose a lot of time. But let's say the 2-4 is a really good document for assessing maturity. You can assess your own maturity of processes, and you can also assess maturity of service providers. And where it really helps, at least in my experience from automotive, for example, it helps to align your maturity level with the maturity level of service provider. And this ensures that your service provider can fulfill their obligations, maybe SLAs or contractual obligations, in a way that you are able to integrate into your own processes. Next one, I think this one is the most familiar with all of you. The system part has two really good standards. One is for the risk assessment, security risk assessment, and the other one is security requirements and security levels. And I think most of you that are already somewhat familiar with IEC 62443 for sure know at least about this one, because this one is the center for defining security levels. It's a base for assessment together with a 3-2, and they together make the core of current mainstream IEC 62443 implementations or applications. Last one, the component part is also interesting. First one, from the perspective of product security development, which means the 4-1 covers the way that products are developed. So if you are, for example, these two are also the only ones for which you can get certification at the moment. So you can have, for example, I know a lot of SCADA products, a lot of ICS products have certifications for 4-1, which means that during their development, so the whole life cycle of the product from development to implementation, to preparing patches and so on, is done in a secure way. So this is a certification that the product can achieve. And the 4-2 is technical security requirements for components. So this one is the hardware part of the standard. And this also means, for example, if equipment you are buying, OT equipment, for example, switches, also can be PLCs, industrial routers, and so on. If they have certifications, this means that they are able to provide a certain security level if configured correctly. So they don't do it on their own. It's not something magically out of the box, but they have capability to reach a certain security level. And that's what this standard is about. Maybe some general principles of the IEC 62443. It covers various topics and brings them together. So that's the core. If we compare it, for example, to ISO 27000 family, this one, the IEC 62443, is a lot more concrete. So it establishes the security context, describes all the components that come together, what their role is, what their function is, describes concretely what the objectives of security are, what is the purpose, what is the role, and there is of course some room for interpretation, as always is, but it's a lot more concrete and can actually help you get started. It includes defines the response elements and covers their role. So people, process, and technology. So these are the three main components that make up every system, also from cybersecurity perspective. This is really important because mostly, I must admit from my experience, companies, so either providers or customers, tend to focus on technology. So they want to buy the next state-of-the-art OT anomaly detection software. They want to buy next state-of-the-art endpoint protection or XDR solution. But where you have to actually start is with people and processes. And that's where IEC 62443 is really good, because it helps you also take those steps. Next, the approach for everything cybersecurity related in IEC 62443 and OT is risk-based. So we always assess risks. We have to find out about risks. What is the tolerable risk? What is the leftover risk? And what kind of risk are we trying to mitigate? And when we know about the risks, we are controlling them. So we're either engineering them out, taking them out of the picture. We're transferring them. Sometimes they can be transferred. One process would be to, let's say, transfer part of the risks to certain functions in the company or other companies to manage them. And part of the risk management are also compensating countermeasures, which means this is something that's maybe not so familiar in IT. Sometimes, for example, if we have a really old PC, really old server, like 20 years old, or let's say Windows 2000 server, and we cannot really remove it, we cannot shut it down, we cannot upgrade it, but the compensating countermeasure would be to place a firewall before the server, in front of the server, and hide it in a way. Or sometimes containerization would be a countermeasure. But it means that we are able to control risks also by compensating with other means. Least privilege, I think we are all familiar with this, and it's the same in OT as it is in IT. One really important is defense in depth. The concept of defense in depth comes from IEC 62443, and it means in relation, for example, to compensating countermeasures, it means that we don't have just one protection method for a certain asset, but we have defense that's made up of layers, sort of like an onion, for example. If you imagine, on the outer side we have the physical security, we have protection with fences, with cameras, with the locks on the doors, and then as you're moving in towards, let's say, level 0, level 1 in the infrastructure, you have protections that are focused on system integrity, maybe password protecting PLCs, protecting the code on the PLCs, and so on. That's the idea of defense in depth. It gives you time to detect the intrusion before something really bad happens. It was already mentioned, supply chain security. It's a critical point, and we are usually in supply chain dealing with either providers, assessing provider maturity level, and it's also really important in relation to 4-1 and 4-2 requirements, because in OT, I think the concept of supply chain security is one of the pain points, one of the biggest pain points, because it doesn't help you to have really good and secure latest equipment from leading automation provider globally if you don't implement it correctly, or if you program some solutions with hard-coded passwords. There's nothing that major providers can do to secure you from that. And as already said, yeah, security and safety are two sides of the protection aspect. So as far as components of IEC 62443 go, we're now moving towards more practical aspects. It defines the taxonomy of the system. So what is the system made up of? What can be components of the system, and what is their role in this in the whole solution? It defines life cycles of automation solution, which means the higher level of equipment, and the processes that take part in these life cycles. So life cycles are from, let's say, development of the solution, the sale of the product, implementation, integration of the product, to operation of the product, maintenance of the product, and in the end, also decommissioning. So this is what's meant by life cycle. And there are processes that take place in each of these life cycle phases. It defines really well the principal roles. So on one hand, we have the asset owners, and then we have system integrators, service providers, and manufacturers, and what their roles are, where the roles are important, who covers what. And here it offers a really strong base for implementing solutions. Or let's say it covers every role and its relation to other roles, and based on the actual life cycle. Zones and conduits, let's say more technical parts of the standard. So the definition of zones for OT equipment, and how the segmentation is done. So zones are, let's say, result of segmentation, result of analysis of the OT environment, and the conduits are actually connections between zones. The communication channels through which communication takes place. And here, maybe what I think this is one of the parts where sometimes it can really get complicated. From my experience, when you are doing OT, but maybe you're not doing it in the best way, because there are some provisions in the IEC 62443 that are maybe not the most logical ones from IT perspective, but from OT perspective, they make perfect sense. Maybe one example I can give at this point, and it's really relevant. If we have, for example, automation system, and part of the communication takes place over IT equipment, for example, that's why IEC 62443 requires separate physical network for OT, for manufacturing. And even within OT, there are some limitations as to what kind of traffic can you what kind of traffic can you have, and what kind of traffic makes everything more complicated. For example, when you're dealing with safety instrumentation, and you have, for example, a kind of Profinet traffic that's called ProfiSafe. This is the traffic that makes sure that when you push the red stop button, everything stops within several milliseconds. When you have this kind of traffic in a network, all the ideas change. And that's why, for example, we were talking about zones and conduits, and what kind of traffic is present in the conduit. And if, for example, you have safety instrumentation, ProfiSafe traffic on a conduit, it makes it a whole different criticality. And then you have to make provisions for that, and you have to make some measures and so on. Next on the list, we have security levels, the famous ones. There are 4. Some people say there are 5, but the 5th one is level 0, which means there is absolutely no security, and you're not protected even from a simple mistake. So sometimes you will encounter safety levels from 1 to 4, and sometimes it will be mentioned that there are 5 from 0 to 4. Each one corresponds to they fall into 7 foundational requirements, and together they make, let's say, the technical part of the definition of what kind of level a system is achieving, and what kind of security maybe system should be achieving. Next, maturity. Maturity is another scale, and it's usually encountered not in the 3-3 or 3-2, so it's not risk topic, but it's more of a topic of capability, or let's say the ability to perform. It's encountered in, for example, 2-4, and maturity is a scale. It's also 4 or 5, again depending on the definition. Maturity is a scale that you can use to describe or quantitatively or qualitatively rate your processes. So how are processes performed, either in your organization or in the organization of a service provider? So they're ranging from everything is done on a per case basis, and it's usually with similar results. So this is not really good maturity, to the level of maturity where everything is performed according to a process, everything is documented, everything is done the same every time, and there is an improvement process behind it. Let's say this is one of the higher maturity grades. But it's actually a grade that's based on C2M2 framework. And in the end, we have the security program rating. So SPR. SPR is not encountered a lot. I must admit, I also didn't encounter it practically often, but it's the program rating of the whole solution. So security levels, for example, security levels are assessed for, let's say, an automation system, or as it's called in IEC 62443, system under consideration. As you see, we have, let's say, we can perform an assessment and we can calculate some security levels. And the security program rating is something really similar, but takes into account also processes and people. And why it's not encountered that often, usually during assessments, the assessment for so the cybersecurity assessment for system under consideration also takes these things into account. So in a lot of the cases, the security levels and the SPR is actually the same. There are also 4 or 5 grades, and they're the same. So let's try to get more practical. In order to achieve some practical results, I believe several things must come into place. So we need some maturity. We need, let's say, the perspective of security, of industry that we're operating in. So which vertical are we in? What kind of provisions are there or requirements for our industry? We have to take into account legislation. We have to take into account the goals of our organization. So what are our goals, or customer goals? What kind of restrictions there are? So either legal restrictions, operating restrictions, financial restrictions, whatever. And the people. People, I think, are the crucial part, because we have to bring together people in the organization and the external people. So usually we have a lot of various internal and external stakeholders, and all of these 6 play a role in the actual result. So how do we get to the result? One proposal, what we have come up with in NIL, is so-called Secure Industrial Operations Blueprint. That's a name we have given to a document that emerges as a result of cooperation between NIL and the client. And on the client side, we have various stakeholders, like mentioned, internal, external. The whole, let's say, preparation of the document, creation of the document, takes up to 8 weeks typically to complete. It depends on the size of the organization and the goals that are agreed in upfront. And as mentioned, on the customer side, what is critical is the IT and OT cooperation. And on the OT side, we are talking mostly about production or maintenance teams, sometimes procurement, depending on how the processes in organization are organized. The focus is combined, which means we are looking at the organizational industrial operations as organization in whole, and also already mentioned system under consideration. This is usually one part of the automation system that's performing end-to-end process. So we take one process or one production process and analyze it, and based on that, we then compile the results. it's done in several phases. Unfortunately, it can't be done in one iteration, because we first have to get some information, some insight into current maturity of the organization, where we are standing with the customer. Then we have to do some exercises related to risk exposure in relation to cybersecurity. And after that, we combine it with customer requirements and let's say pain points. What are the actual goals? Pain point can be translated to a goal, so that we can define the objective. And after that, we are able to focus on the actual execution. And during execution phase of the blueprint preparation, we are going through it step by step. So we have several workshops which have proved to be the most effective way to have this cooperation. We assess the site, so the actual system under consideration. We perform a walkthrough of the SUC, take a look at how systems are integrated, how production process is running, how it integrates with other parts of the production. And we create this ASIS picture, ASIS state assessment. Part of it is also the cybersecurity assessment, where we assess it based on the 3-2 and 3-3 chapters. And sometimes, depending really on the vertical industry, so if it's an automotive company, we usually take into account also provisions, for example, that are related to TISAX or VDA, ISA. And we can also perform OT scan. So OT scan sometimes is also part of this execution phase, but this really depends on the maturity of the customer and on the OT environment. So scans can be active or passive, using OT specific tools. So we don't use IT, let's say IT pen testing tools or platforms that are IT specific, but we use tools which are, let's say, engineered to be as unintrusive as possible, and they're also able to adapt to a specific automation system, so that results can also be used as an input for preparing the document. So what the blueprint actually is about, it's a kind of a strategic plan. So it's a document that you can use as a base of strategy for development of OT for growth. And it contains, in the end, of course, it contains all the findings, but also detailed projects in, let's say, their order of appearance or their order of priority, that you can then use and implement also together with us, if you choose to, for reaching those goals. And the proposals, why we do all those, why we go through all the workshops and all the discussions, the idea is to reuse or reconfigure existing technology that's already present, or leave as much in place as possible and add new technology, but we're always focusing on, let's say, 360 degrees of the industrial operations. Of course, I have to put in an asterisk here, because we don't do automation level. We don't go to, let's say, we cannot tell you what kind of PLCs you use, but we can help you secure them and have, let's say, reliable industrial communication. And what I like to think about of this document is it's kind of a living strategy. So it's a document that you take away, that you can put somewhere, most likely on a desk, and read it as often as you can, to see where you want to go and how are you getting there. What kind of topics are covered? So it's ranging from OT network to segmentation, so definition of zones, definition of conduits, It covers remote industrial access, so remote access to OT equipment. It includes authentications, authorization, for all kinds of equipment. We're not, in authentication and authorization, we're not talking about authentication on PCs. We're talking about overall identification of users. It includes incident detection and response. So anomaly detection, response to anomalies. It contains business continuity, industrial data center, industrial DMZ. Some of these topics have already been covered before. Some of them are maybe new, have emerged in the past few years. IT and OT integration. Then another topic that's really interesting, industrial backups. So we all know how to back up virtual machines, virtual workloads, containers, physical PCs, servers, but what about backups of PLCs, for example, and configurations of your OT equipment? This is also something that needs to be taken into account. And when we get here, when we're at this point, we have the blueprint. Now what? The implementation. A short overview of activities. What really needs to be done, I believe, and I haven't seen proof of otherwise, it has to be taken step by step. So you have to approach it step by step. And here it's some of the activities are sorted from bottom up. And I think the shortcuts here are not, maybe they are possible, but I have prepared this based on my experience, and you always need to have a solid foundation. So if you have a solid industrial network, you can play with partitioning, segmenting. You can then implement anomaly detection solutions. You can start looking for anomalies in the traffic, in the communications. Of course, authentication and authorization is needed quite early on, because you have to make sure you know who is doing what. And if you move through the list, maybe some topics can be interchanged. Maybe it's based on your organization, or perhaps on your maturity level. But if you're moving through all the topics, and if you're covering them, you are slowly progressing towards the state where you can perhaps even consider managed OT services. Because if you have all the foundations there, if you're prepared, you can move to managed OT and maybe trust someone with part of the responsibilities for your network. And how does the actual implementation then look like? Maybe I have included here two reference architectures, and there one is from the leading OT automation equipment vendor. The other one is from Cisco, and they both show the same components in almost the same way. So what you end up with is a modern OT network that is segmented in accordance to the functions that it performs, and contains the components that I have mentioned in previous slides. And this is something that can come up as an end goal for your organization. When you go through the blueprint creation, we come up with a similar architecture, but that one is tailored for your organization, for your scenario. And that's why I like to call it a living strategy, because you can go back, take a look at it, and see where you want to go and where you are. We have come to the end of the webinar. So a short takeaway list. IT and OT, they are merging. They're coming together. We call it convergence. We call it collision, whatever you want to. But the thing is, the results can be extremely positive. Of course, they can be negative as well. We can have some. I've seen organizations where IT and OT do not really work together well. But if the discussions are synchronized, if they're aligned, the results can be beneficial, multiplied for the organization. NIST, yeah, it's here, it's coming. It's implemented in most of the countries, and sometimes the complications are bigger in some countries. The requirements are stricter than in others, and you can manage it, of course, but you have to do it step by step, and implementations really have to be thought through. IEC 62443 remains the main standards framework for risk-based industrial cybersecurity. Despite having some alternatives like NIST, there have been some tries from ISO 27000, some sub-documents, but they're mostly focusing just on bare-bone compliance, not really how do you do it. And the last one, people, processes, and technology. I think that's the most important one. Don't focus just on the technology to help you get somewhere. Don't buy the latest state-of-the-art product if you don't have the people that will work with the product, and if you don't have the process that takes that product into account, if it doesn't include that product throughout the life cycle. That's really also important. Don't just implement something, but when you implement it, you have to use it, you have to operate it, you have to maintain it, and you also have to prepare for offboarding or decommissioning when time comes. So that way you're not stuck with, for example, 2 CMs in your company. I hope not. So this is it for now. We will send you all the recording and the presentation will be shared. I would like to invite you to fill the post-webinar survey. And if you have any follow-up questions, of course, they're more than welcome at my email address, or you can also reach your local Conscia office or account manager for booking a meeting or talking further. I'm really happy whenever I have a chance to talk about OT and cybersecurity, and I will really be happy to answer all of your questions. Thanks.